to a video tutorial working on algebra problems, specifically algebra word problems, and in this example, distance, rate, and time. So we've got a kind of an easier distance, rate, time problem to help you if you're just getting started with these types of word problems. But they're really common, but they use this relationship that we have in real life, and that the fact that the distance you travel somewhere is equal to the rate of speed you're going. Obviously, the faster you go, the farther you go. But it's also multiplied by how long you're going at that speed, the time. So again, that's distance equals rate times time. And there is a plethora of word problems that use this simple relationship but get into all sorts of instances in terms of buses and trains and planes and walking and biking and multiple people and all that good stuff. So hopefully some of these examples that we go over with distance, rate, time will help you make sense of it, understand how to put it into algebra equation and solve some of these types of problems. Let's take a look at this one that we got here. You're driving a car and are planning a trip that is approximately 820 miles long. All right, that looks like a distance. I'm going to go ahead and label that D. If the trip took you 15 and a half hours, that looks like a time. I'm going to underline that for T, to drive. Here's the question. What was your average rate of speed? That's my rate. So I'm trying to find the rate. Let's think of what we got here. So the distance we just saw in the problem was 820 miles. Make sure to keep track of your units. That's important in these problems. The rate, our rate of speed, we don't know what that is. And our time, we took 15 and a half hours. So I'm going to call that 15.5 hours. All right, let's put this into an equation that we can solve. So we have 820. If I substitute that in for D, equals the rate, I don't know what that is, but I'm going to solve for it, and time I'm going to put in 15.5. You can see it's a pretty simple equation now. So to solve for R, I just need to divide both sides by 15.5. Those divide each other out. It's a one-step equation, and so my rate is equal to whatever 820 divided by 15.5 is, which is approximately, if I round it, 52.9. So the rate is 52.9 miles per hour. So the rate has to match up with the units of time and the units of distance. All right, there's a good introductory problem for distance, rate, and time.